Have you ever wondered how our software works with external tools? Today we will learn how our OBD2 and J1939 dashboards communicate with a scanner and external software. I'm Sani from INPRONIC USA. Let's get started. We connect our trainer, both the upper board and the lower board, through a USB cable. On the splitter, we connect the chassis ground and the signal ground to pins 4 and 5. On pin 16, we connect the power supply. One end goes to the scanner, and the other end connects to the trainer. We open our Pro Edition software in 2 windows to generate a real communication. Once the windows are open, we open our COM port, in my case, COM6. We press open and can see that it's the upper board. Let's start with the OBD2 protocol and a speed of 500 kilobits. Then we press start and the LED 7 will begin blinking rapidly. In the other window, we open the COM port, in my case, COM5, which belongs to the lower board, with the same protocol and the same speed. Then we press start and the LED 7 will begin blinking rapidly. Now we proceed to enter the dashboard. To do this, we set the VIN by pressing the Set button, then OK. We click on the dashboard image, and it will open in the same window. We adjust the dashboard for better use. At this point, we can start it and shift to direct to move parameters like speed and RPM, but that's not what we came here to learn. First, we're going to request real-time data from our dashboard, which is acting as a vehicle. We turn on the dashboard by pressing the engine button, and on our scanner, we press the OBD2 button while shifting to direct gear. At this point, the scanner is accessing the vehicle's system, in this case, our dashboard. Once it connects, we can see that the vehicle's VIN has already been configured. We press enter and start reading the real-time data. As we can see, the request is received immediately, and the software responds with the vehicle's real-time information. Now we're going to filter something specific, the engine RPM. We'll do this directly from the scanner. Once entered, we can see the RPM increase or decrease as we adjust this parameter from the dashboard, just like using an accelerator. For a better visualization, we can go to the analog data bar and observe the movement in the same way. Now, let's simulate a fault, detect it with the scanner, and then clear it. We press the check engine button, and a window will open where we will enter the ID, in this case, 7E8. In the data field to simulate the fault, we enter 0x04, 0x43, 0x01, 0x01, 0x02. We press send, and the fault appears both on our dashboard and on the scanner. Now we're going to clear all the DTCs so the fault disappears. We do this directly from the scanner, and as you can see, the fault disappears immediately. Now we're going to learn how the J1939 dashboard works with external software. We switch our protocol to J1939 dashboard and open the ports both windows as well. In one of the windows, we open the dashboard. When we start it, it already provides some information without sending any requests. We open our heavy-duty diesel software, select the J1939 dashboard connection, and the data immediately begins to flow. Once inside, we start modifying parameters like RPM, and we can see that the external software reacts in real time. All the buttons on the J1939 dashboard perform real actions, just like in a real heavy-duty vehicle. All these actions are detected by the external software. For example, if we lower the water parameter on the dashboard, we can see the temperature warning light turn on and an alert appear in the external software. Every parameter can be modified and triggers alarms, allowing you to see how a real heavy-duty vehicle reacts. Once again, thank you very much for watching this video. Remember to follow us to keep learning more about CAN-BUS communication.